Okay, so now this is the second part of the chemistry practice final for fall semester. And we are going to do numbers 14 to 26. So number 14 says chlorine gas will react with ethylene to make quadrachloroethylene and write the balanced equation. Okay, so we are given, so chlorine gas, and so you need to remember that chlorine is a homonuclear diatomic, so it's going to be Cl2. And then we're given the formula for ethylene, so that is HC2H2. And then it says that those react with each other to make, the product will be C2H2 Cl4. Okay, so that's our chemical equation, and then it's just a matter of balancing it. The carbons are okay. There's 2 carbons on each side, and the hydrogens are okay. There's 2 hydrogens on each side. Here we have 2 chlorines and 4 chlorines, so we can fix that by just putting 2 molecules of chlorine gas. And number 15 says balance the following equation. Okay, so you should recognize this as a complete combustion reaction. We add oxygen. The ethanol reacts with oxygen to produce carbon dioxide and water. Okay, so let's start by balancing the atoms that are only present in one molecule on each side. So we'll start with the carbon and the hydrogen. So there's 2 carbons on the reactant side, so we'll put a 2 here to get 2 carbons over there. There's 6 hydrogens, so we'll put a 3 here to get 6 hydrogens over there. So then we look at the oxygens, and here we have, on this side we have 3 oxygens, and over here we have 2 times 2 is 4 plus 3, we have 7. Okay, so we need 4 more oxygens over here. We have 1 here, and we need 7. So we need, from this, if we can get 6, that will give us our 7. So if we put in, if we have 3 molecules of oxygen gas, and that gives us 6 here and 1 there. So 7 oxygen molecules on each side. Okay, number 16, write the balance equation for the formation of PH2Br. Okay, so a formation reaction just means that you're going to combine the individual elements to make this molecule. So it's going to be P plus H, and hydrogen is a homonuclear diatomic, and then plus the bromine, and bromine also is a homonuclear diatomic, and that's going to, our product will be PH2Br. Okay, so then if we look, the hydrogens are okay and the phosphorus are okay. The bromine, we have 2 bromines here and only 1 there. So let's put a 2 there. Now we have 2 phosphorus, so we can fix that. And now we have 4 hydrogens, so we can fix that by putting the 2 there. Okay, so that is now balanced. Okay, number 17. write the balance equation for the decomposition of Na2CrO4. So decomposition is just going to be, it's going to decompose into its elements. So it's going to decompose into sodium plus chromium plus oxygen, and oxygen is a homonuclear diatomic. Okay, so 2 sodiums on the left side, so let's put a 2 there to get the sodiums. Chromiums are okay. We have 4 oxygens here, and we can get 4 there by doing that. So that is now balanced. Okay, number 18 says that a chemist has 12.3 moles of N2H4O3. And the question is, how many grams is that? So we're converting to grams. So grams is going to go on the top, and moles will go on the bottom. So we have to figure out how many grams is in a mole of N2H4O3. So we have 2 nitrogens. Each nitrogen is 14.01. We have 4 hydrogens. Each hydrogen is 1.01. And we have 3 oxygens, and each oxygen is 16.00. So adding all that together, we get 80.06 grams is equal to 1 mole. Okay, so then we just plug that number in up here. So there are 80.06 grams in 1 mole. So moles are going to cancel. You'll be left with grams of N2H4O3. And if you do that math, you should get 984.738 grams. And we can have 3 significant figures, so we'll round that up to 985 grams. Okay, number 19. A chemist has 0.45 moles of K2CO3. If it decomposes into its elements, how many grams of oxygen will be made? Okay, so the question is how many grams of oxygen. Okay, so we were told it's a decomposition reaction, so the K2CO3 is going to be decomposed into potassium plus carbon plus oxygen, and oxygen is a homonuclear diatomic. Okay, then we need to balance that. So we'd have to put a 2 here for the potassium. And then for the oxygen, we have 3 here and we have 2 there. So the least common multiple is 6. So let's put a 2 here. That gives us 6 oxygen there. We put a 3 there. That gives us 6 there. Now that messes up the potassium and the carbon, but those are pretty easy to fix. So we have 4 potassiums. So we'll just change this to a 4. And then we have 1 carbon. Now we have 2 carbons, 2 times 1, so we have 2 carbons. So let's put a 2 there for that carbon. Okay, so So now we know the chemical form, we know their chemical reaction, so now we can start with that 0.045 or 0.45 moles of K2CO3, and we can go, since that's in moles, we can go right into stoichiometry, and we want to know how many moles of oxygen. So there are 3 oxygens for each 2 K2CO3. So the K2CO3s are going to cancel. You'll be left with moles of oxygen. So 0.45 times 3 divided by 2 will give you 0.675 moles of oxygen. Okay, so that's moles of oxygen. We were asked for grams, so we just need to convert that then to grams. 0.675 moles of oxygen. We're going 2 grams, so grams will go on top. And for O2, there's 2 times 16.00. So it's going to be 32.00 grams in 1 mole for oxygen gas. Okay, so 32.00 grams is 1 mole. So moles cancel. You'll be left with grams of oxygen, and 32 times 0.675 with 3 significant figures is 21.6 grams of O2. Okay, number 20. How many atoms are in 150 grams of gold? So we're going to start with 150.0 grams of gold, and gold is AU. Well, the relationship that we know is that 1 mole is equal to 6.02 times 10 to the 23rd atoms. So we're asking atoms. So we need to get those grams into moles before we can go to atoms. So 150.0 grams of gold. And if you look on the periodic chart, you will see that for gold, 1 mole is equal to 196.97 grams. So grams are going to cancel. And 150 divided by 196.97 with 4 significant figures is 0.7615 moles of gold. Okay, then now we can apply this to get the number of atoms. 0.7615 moles of gold times 6.02 times 10 to the 23rd atoms in 1 mole. Okay, so moles are going to cancel. You'll be left with atoms of gold. And with 4 significant figures, you will get 4.584 times 10 to the 23rd atoms. So in that one we had to go, we were given grams and asked to find atoms. And the relationship we know is between atoms and moles. So we had to first convert this to moles. Once we knew the number of moles, then we can use Avogadro's number to get the number of atoms. Okay, number 21. says if a fireplace has poor airflow, what type of reaction should you be concerned about and why? So first of all, with poor airflow in a fireplace, you can get incomplete combustion. And remember that with incomplete combustion, the products that form are carbon monoxide and water. So this carbon monoxide is what you would need to be concerned about because that is a toxic gas. With complete combustion, you form carbon dioxide. With incomplete combustion, you will form the poisonous gas, carbon monoxide. Okay, number 22 says when atoms share electrons to make a molecule, is the compound ionic or covalent? So sharing of electrons is covalent. In an ionic compound, the metals actually give up their electrons and the non-metals receive those electrons. So they're not sharing, they're actually giving away and taking. So sharing of electrons is a covalent compound. Okay, number 23. One type of stomach acid, AlOH3, can be made in the following way. Okay, so we're given this chemical formula. Okay, and in this problem, it says how many moles of this can be made with, if you start with 2.3 moles of this and excess of this. Okay, and remember that the only reason we're told that excess of this is that that's telling us that this is not the limiting reactant. So this is called sodium hydroxide. This would be the limiting reaction, but we're told how much of that we have and how many moles then of this would we have. Well, since this is in moles, we can go right into using stoichiometry. So 2.3 moles of NaOH. And there are 2 of the AlOH3 for each 6 of the NaOH. Okay, so NaOH's cancel. 2.3 times 2 divided by 6 will give us 0.77 moles of AlOH3. Okay, so that one, because you started out in moles and needed to know moles of the others, it was simply a matter of using stoichiometry and looking at the ratios. Okay, number 24. A chemist has this reaction, and these are the CL. This is Cl, not Ci, so it's chlorine. Okay, so there's our reaction, and it says if a chemist wants to make 50 grams of this, so 50 grams, 50.0 grams of this, how many grams of this will be needed? That's our question, how many grams of that? Okay, so in order to look at so we don't have to worry about the water and we don't have to worry about the HCl. And in order to look at the relationship between different compounds, we have to be having in moles. So the first thing we're going to do is convert this to moles. So 50.0 grams of HClO3. We're going 2 moles, so moles will go on top. And for H, we have 1 hydrogen, we have 1 chlorine, and we have 3 oxygens. So 1.01, the chlorine is 35.45, and 3 oxygens that are 16 each. So that tells us that for this compound, 1 mole is 84.46 grams. Okay, so 1 mole is 84.46 grams. Okay, so grams are going to cancel. You'll be left with moles. 50 divided by 84.46. You will have 0.592 moles of the HClO3. Okay, now that we know the number of moles of the HClO3, now we can look at its relationship to the ClO2, which is what our question is asking. So 0.592 moles of HClO3, and there are 6 of these for each 5 of those. 6 ClO2s for each 5 HClO3s. Okay, so these HClO3s are going to cancel. You'll be left with moles of ClO2. So 0.592 times 6 divided by 5 will give you 0.710 moles of ClO2. Okay, so we're not quite there because we want the answer in grams, so we just need to convert these moles to grams. 0.710 moles of ClO2. We're going 2 grams, so grams is going to go on the top. How many grams is in a mole? So for ClO2, it's going to be 1 chlorine and 2 oxygens. The chlorine is 35.45. And there's 2 oxygens, so 2 times 16. So add that together, it's 67.45. Grams in a mole. Okay, so 67.45 grams in 1 mole. Moles cancel. And we finally have our answer then, which is 47.9 grams of ClO2. So if you want to make 50 grams of this, then you would need That should have finished up all of question number 24. Okay, then 25 says, so we have this reaction, manganese oxide plus 4 hydrochloric acids will give us MnCl2 plus 2 waters, and then plus chlorine gas. Okay, and the question says, a chemist makes manganese chloride. Okay, so making this with this chemical reaction. When their reaction is run, plenty of this is made. There is also water, chlorine gas, and HCl present. What is the limiting reactant? So since all of these 4 things are present, that means that they're not the limiting reactant. There's still, for the hydrogen chloride, there's still, if it's still present, that means there's more of it that could be used in a reaction. So the limiting reaction must have been the manganese oxide. Okay, then lastly, number 26, nitrogen becomes liquid at negative 346.0 degrees Fahrenheit. What is that temperature in degrees C? So degrees C is equal to 5/9 times the Fahrenheit temperature minus 32. Okay, so 5/9 times negative 346.0 minus 32. So that's going to be 5/9 times negative 378.0. And so the answer that you will get will be negative 210. And we need to go out to the 10th place for a significant figure. So negative 210 degrees Celsius. Okay, so that should finish up all of the questions for the practice final for chemistry.